Hey, seventh grade, welcome back. Happy Thursday. It is May 14th, and today we're going to practice some angle relationships. It's been a while since we've seen these, and I love this part of geometry, so I'm excited to work on it with you today. Before we get started, just a reminder that because today is Thursday, we are hitting our final topic of the week today. And then your independent practice today is a quiz that covers everything we've done all week. So we've done area and surface area and volume. We're getting into angle relationships today. So that will all be on your quiz. So in a minute, I'm going to give you a chance to pause the video to make sure you have all of your notes from this week's lessons. You are welcome to use those notes, and I encourage you to use those notes on your quiz today. And we'll take some more notes on angle relationships today that you'll need for your quiz. So go ahead and pause here and make sure you have everything that you need. All right, a quick review, because it has been a little while, let's review what angle relationships we are going to be using today and that we have used in seventh grade. The first is complementary angles. The first is, yes, these are angles like this angle alpha and angle beta that are labeled here. Those are just Greek letters, and they represent different amounts because they're different letters, kind of like a variable. These are angles that add up to 90 degrees. Together, they form a 90-degree angle called a right angle, called a, so two angles that form a right angle are called complementary. Now, they don't have to be next to each other. If I pulled these angles apart or I put them next to some other angles, we would still say that angle alpha over here and angle beta over here are complementary if they add up to 90 degrees. Let's look at these two. See angle alpha and beta. These are different angles now, same letter. Adjacent angles are angles that are next to each other. So angle alpha and beta here are adjacent angles. These two angles are also adjacent. Adjacent is not talking about what the angles equal. It's not helping you solve. It's just talking about angles that are next to each other, okay? Take a look at these. This is another important one. These are called supplementary angles. These are called, yes, these angles are on a straight angle or a straight line. So angle alpha, which is this acute angle here, and angle beta, which is this obtuse angle, form together one complete line like a horizon, like a sunrise. And so these two angles form a line. We know that a line has 180 degrees. We call these supplementary. Again, if I broke them apart or if they were in different parts of the diagram, but their measures added to 180 degrees, we would still call them supplementary. And last one, and maybe my favorite one, are vertical angles. Vertical angles are across from each other. What do you notice is different about the labeling on this diagram compared to the others? Yes, there are the labels with the same variable. They're both alpha. That's because vertical angles are congruent or equal. Vertical angles are, yes, congruent means equal. They have the same measure, so we can actually call both of these alpha. Let's say this one was 50 degrees. It means this one is 50 degrees too. Okay, and those are opposite of each other. Let's see if we can identify some of these angle relationships in diagrams. Take a look at this guided practice question. What angle relationship do you see here? If you said complementary angles, you are correct. Nice job. These are complementary angles because these two angles, x and this 15-degree angle, form a 90-degree angle. Go ahead and use your reasoning. Can you figure out what the value of x is? All right. I do want to introduce a strategy to you or really remind you of a strategy that you already have learned. And I forgot to read it in this previous slide. What we're going to do today is use equations to help us represent angle relationships. So we're modeling geometry with algebra, which is really exciting. But the reason that we're doing that is because we've worked so hard on our algebra skills over the last couple of weeks. We can really use that to our advantage as we start to work through some geometry questions. So looking at this picture, what do I know? I know that the angles shown are complementary, and I know that the two angle pieces are called x and 15 degrees. I know that the sum of the two angle measures is 90 degrees. So I can write an equation that says x plus 15 equals 90. Then I can solve for x using the same strategies that I've been using the last few weeks. I'm going to subtract 15 on both sides. And I know that x then must be worth 75 degrees. That was answer choice B. The strategy of writing an equation you might not have needed in order to get the answer for this question. That's because it wasn't very tricky. There was just x and 15. In the next problem, there will be more terms, and you'll need to use this equation skill. So go ahead and pause here and make sure you have this written down and you've had time to think about it and understand it before moving on to question 2. Awesome. Let's go ahead and move on to question 2. I want you to solve this one on your own. Let's take just a minute to do this one. Oops. All right, and there's your question back on the board. 1 minute. Please begin. The first thing I want you to do is identify what angle relationship is shown in the picture and use that to help you write an equation. We're halfway through our time. You should have your equation written. These are complementary angles, so they should add up to 90 degrees. Try combining any like terms before you start solving. All right, it's okay if you didn't quite have time to finish. We'll catch up together. Here's my work for question 2. These, of course, are complementary angles. They form a 90-degree angle. So I know that the sum of the angle measures included there was 90 degrees. Okay. If I look at this picture, I see that this angle is 2x, and this angle is this whole expression, 3x plus 5. So I wrote 2x plus 3x plus 5. I don't need parentheses because of my associative property, and that does sum to 90 degrees. My reminder to you while you were working was to try combining like terms before you finish solving. I know that 2x and 3x are like terms, and together that's 5x plus 5 equals 90. Now it's a two-step equation that I can solve. I subtracted 5 on each side. Then I divided each side by 5. And I got x as a value of 17. Please pause here and update your paper if you need to. If you got this one on your own, put a big star next to question 2. Really excellent work. Awesome. Go ahead and enter your answer now for guided practice question number 2. This is the first question in your Google form. Awesome. Let's move on. Guided practice question number 3. I really want to work on this one a little bit more together, at least set it up together, because I want to give you a reminder I haven't given you already. Maybe you know this, maybe you remember it. This question has a right triangle in it, and it says solve for x. I can see that angle A has x degrees, angle B is 2x, and angle C is 90. Do we know anything about the angles inside of a triangle? Yes, we've seen lots of proofs this school year. Maybe you remember tearing the corners off of the triangle and lining them all up. Do you remember this? If not, it's a great thing to YouTube later. The sum of the angles inside of a triangle are, they add up to 180 degrees. They are supplementary. So we say that the sum of the interior angles of the triangle is 180. So let's use that information and write an equation, okay? I know, let me get my screen split up here a little bit. Awesome. I know that the triangle angle sum is 180 degrees. Go ahead and update your paper, please. So if you do want to look at this later, a ton of people have done some cool proofs on YouTube, and I always show these in my regular in the building classes, and we did look at them this year. You can just put triangle angle sum in YouTube and find a lot of cool ones. So I know that the sum of all three angles is 180, so that's the relationship I use to model with algebra. So first step, identify the relationship. Second step, model with algebra, write an equation. Okay. Then same thing, I'm going to combine those like terms first. What is 2x plus x? Yes, 3x. Right? So now I have an equation, 3x plus 90 equals 180. Now solve. I'll give you 30 seconds to finish. $15 seconds. Awesome. You should have subtracted 90 on each side, then you should have divided by 3 on each side to get a value of 30. X is equal to 30. That was answer choice A. That means that this angle A is a 30-degree angle. What's the measure of angle B? Yes, 60, because 2 times 30 is 60. Awesome. The question's asking for the value of X, which we know is 30. That's answer choice A. Great work. I love angles. All right, so we've looked at complementary angles, we've looked at supplementary angles inside of a triangle, and now we're going to look at all kinds of relationships in one diagram. This kind of diagram is points at an intersection, lines at an intersection. So we can see all these different lines are intersecting at this point G. And when we do that, we form all kinds of angles. I see some complementary angles here. I see some supplementary angles here. I even see vertical angles here. We're going to use all of those relationships to try to determine the value of X, okay? I'm going to try to mark up the diagram as we go. Go ahead and jot on your paper number 4. If you'd like, and if you're able to, it might be helpful to draw the diagram. I did not draw the diagram in my notes, but I always think it's easier to mark up the diagram. So if you'd like, one thing you can do is take your piece of paper and hold it up to your computer screen and lightly just trace onto your paper the diagram. Okay, so pause here and do that now if you'd like to. If not, no worries, keep following along. All right, so let's start by reading. In the figure below, this says line segment EF is perpendicular to line segment CD. So EF is perpendicular to CD. All that's telling me is that these two lines make a 90-degree angle. That's what perpendicular means. They make a 90-degree angle. I can see that marked right here. But I also know then that these two angles make a 90-degree angle, and these two angles make a 90-degree angle, and this angle is a 90-degree angle. That's all it's telling me. I'm going to go ahead and erase my annotations so that I keep my diagram looking really neat. All right, and segments AB, CD, and EF intersect at point G. Awesome. What is the value of X? So let's think. I have a few angle relationships that I know. My favorite one to start with in this kind of diagram is vertical angles. So if I don't know right away what the value of x is, and I don't see that it has a buddy next to it that it's complementary or supplementary with, I start with those vertical angles. So I can tell that this angle right here, AGC, 51 degrees, has a vertical angle buddy. Can you find what angle is vertical to this angle? Remember that vertical angles are opposite of each other and they are congruent. Yes, the angle that's vertical to this one or opposite is right here. This angle is 51 degrees. Angle DGB is 51 degrees. All right, does that help me start to solve? It does. Now I see a complementary angle relationship that I can use in order to find the value of x. So I know that these two angles, FGB and BGD, form a 90-degree angle pair. They're complementary. So an equation I can write is x plus 51 equals 90. Now solve. Awesome, did you get it? Here's what my work looks like. All right, I just jotted down, when I did this ahead of time, I jotted down my vertical angles and complementary angles that I used to find the value of x. But here's that equation. I got x is 39. That was answer choice A. Awesome, let's try another one. We're still gonna do lines that intersect. This question, I believe, was on a test or a quiz that we did earlier this year, and it's really tricky. You've got to do a few steps in order to get there. But again, always I'm first identifying what I need and then looking around it and see if I have anything already. If I don't, I'm going to start looking at those vertical angle relationships, okay? I'm going to give you a minute to try to tackle this one on your own. Remember, you have that strategy of holding up your notes to the screen and just tracing the diagram lightly. If you do that, just make sure you're not pushing too hard and so you don't mess up your computer screen, and also just make sure you're moving efficiently. It does not need to be perfect, okay? Go ahead and begin. Just take 1 minute on your own. So find the measure of angle VPQ. Angle VPQ is over here. So it's this angle measure on that sort of bottom right side. This is the angle we're looking for. Try to start by using vertical angle relationships to identify angles that are next to it. All right. I love this question. There's a lot of ways you could solve. So if you solved a little bit differently than I did, no problem. I am looking for this angle over here. I don't have any adjacent angle measures. I do see that it would be supplementary to this one and this one. Like these three together would form 180, but I don't have any of those measures. So that doesn't really help me yet. But there are vertical angle relationships that I can use, and I'm going to in order to solve. So I see that this angle right here is given, this 62 degrees. What angle is that one vertical to? Yes, it's vertical to angle RPQ, right on the other side. What does that tell me? It tells me that this angle right here is 62 degrees. All right, even though I'm not solved yet, I know this is helping me because I'm looking for this angle, and I know that this angle and this one are what kind of relationship? They're supplementary. So I'm on my way to figuring it out. Now I'm going to try to find this one. Let me switch colors again. Okay. I do know that this angle right here is vertical to this one. So what's the measure of angle UPV? Yes, 35. 35 degrees. Okay, go ahead and update your paper. So what do I know? I know that the angle I want, let's call it X, doesn't matter, plus this one is on that 180 degrees. It forms like a sunrise, right? So that's the relationship I use to start to answer my question. 35 plus X plus 62 equals what? Yes, 180. That straight line has a 180 degree relationship. Now I solve. Okay? If you got this far, excellent, excellent job. If you did not get this far, please pause the video here and make sure you understand how we got this equation before moving forward. It could be helpful to rewind and watch this part again. All right, so then looking at my work, here's my equation. I wrote the terms in a slightly different order, but that's okay, still equivalent. When I solved, I first combined the like terms. The constant terms are like terms. Then I'm going to subtract 97 on each side, and I got a value of X equals 83 degrees. Awesome, so that's my answer for question 5. Go ahead and pause the video here and make sure your work looks like mine before we move forward. Awesome. You're going to go ahead and enter, this is our second video question. Enter the answer, please, for question number 5. Just put the number, don't put the unit or a degree symbol or anything like that. Just put the value of X as a number. Pause and do that now. Awesome. It is here, your question of the day. I want you to fill in the blank. Blank angles are congruent. Blank angles are congruent. This is an angle relationship. Let me go back to my reference picture here. Which of these angle relationships shows congruent or equal angles? Yes, vertical angles are congruent. Vertical angles are congruent. So where it says question of the day, your third video question, I want you to fill in the blank. Vertical angles are congruent. Beautiful. All right, I hope you enjoyed that angle relationship review. I wish we had a lot more time to review angle relationships because I think they're so fun. Your independent practice today, I'm going to actually adjust this. It's your quiz, remember, for the week. So your goal is to complete your quiz today. There's no skill builder today so that you have all of your time and focus just devoted to that quiz. Can't wait to see how you guys do on our learning from the week. As a reminder, please check Ms. Russell's post update on office hour time, and I'll see you back here tomorrow for your next assignment. Bye.